Next, I'll show you how to solve the ALEKS problem, label the electrophile and nucleophile for the Lewis acid-base reaction, along with drawing the structure of the products. So what ALEKS is going to do is going to ask us two questions for the most part. It's going to show us these two elements kind of towards the top, or these compounds towards the top, and it wants us to label them as either a nucleophile or electrophile. And then the second part is just overall just drawing the structure when they come together. I have some simple rules for this question. So rule one is that the nucleophiles donate a pair of electrons to form a new bond. Electrophiles are a species that accept a pair of electrons to form a new bond. And then the pro tips that I have for this one is that you look for the lone pairs and negative charges and think of what is capable of creating bonds, and that'll be your nucleophile. And then at the end, once you solve this, you just want to check the charges to ensure that everything is right. So we'll start by looking at the two structures. We see that we have the oxygen along with this purple group that's attached to it. And we see that it has lone pairs, negative charge right there. So it's safe to say that we can label this, and I'll just drag it over. Sorry. This would be our nucleophile. Now with aluminum, we see that it has three charges already to it, or it has three bonds on it. And as you see, no lone pairs. And if you were to look down here at the periodic table, you see that aluminum falls under 3A. So it's pretty much at full capacity. So really doesn't have any room for any lone pairs. So it's safe to say you can drag the electrophile here. Now, with part two, you want to draw the structure of what's going to happen. So I'll help you kind of picture how this will go. So usually I like to start with just the mechanism. So because the nucleophile is going to donate a lone pair, we see that usually it likes to connect right here or really anywhere on the aluminum. And then what it wants us to do is to just draw the product out. So I start right here. I'll draw my aluminum first. And then you see before I have the three bonds that were already on it to begin with. And then next up, we just want to draw the mechanism as it happened or what the product is going to be. So we started with this oxygen with 6 electrons, but we're going to donate one pair so that it could bond with this aluminum right here. And then so that leaves us with 1, 2, 3, 4 electrons left. And then we'll just draw the rest of the purple stuff that was right here, or these 3 carbons right here. So we'll just go 1, 2, 3. And the last thing that we're going to do is we're going to check charges. So aluminum is in group 3A. So from my previous videos, we start with 3. And then we're going to subtract the bonds or electrons that we see around it, which we only see 4 bonds. So 1, 2, 3, 4. So it's going to be -4, and that equals -1. So it's safe. We're going to put a negative charge right here on aluminum. And then for oxygen over here, we see that it's in group 6A. So it'll be 6, and we're going to count the electrons and pairs around it. So this is 1, 2, 3, 4, 5, 6. 6 minus 6 is 0, which is what it is. It's a neutral charge. And this will be your answer. Feel free, again, if this channel helped you or your peers, feel free to like, share, and subscribe to the channel. Thank you.